Fire, both worshipped and rightly feared. But without fire, life as we know it would be impossible. Our civilization, our modern lives are created out of fire. Look around. From fire came the first tools of civilization: pottery and ceramics, plows for farming, weapons for security. Then came the machines and marvels of the Industrial Revolution, the steamships, railroads and automobiles, all made with fire and powered by fire. It's even more incredible today. Cities spreading to the horizon, mass transit, aviation, wondrous electronics, medical marvels, and technologies of the future stretching to the universe. The amazing 21st century, built with iron and steel, aluminum, cement and concrete, and glass, all dependent on fire. But how do we control the fire? What is the secret of taming the flame? The answer is refractories. From a word meaning durable or stubborn, refractories are ceramic materials which are designed to withstand the very high temperatures encountered in modern manufacturing. They line the hot surfaces found inside many industrial processes. Refractories contain the heat and protect processing equipment from the intense temperatures of molten materials and superheated gases. From 1,000 degrees Fahrenheit to 4,000 degrees and higher, refractories protect the industrial processes that serve mankind and make civilization possible. But they are not just used for handling molten metals and ores. Refractories are essential to the manufacture of petrochemical products and the refining of gasoline. They can be found in your family room fireplace and your neighborhood pizza parlor. From flower pots and tableware to porcelain toilets, bathtubs, and sinks, to today's 21st century technology. There are thousands of uses for refractories and thousands of different refractory products. So what are refractories? Refractories are produced from natural and synthetic materials, usually non-metallic, or combinations of compounds and minerals, such as alumina, fire clays, bauxite, chromite, magnesite, dolomite, silicon carbide, zirconia, and many others. Minerals must meet exacting specifications to ensure the durability and effectiveness of the final product. Mined and transported from around the world and right next door, these raw materials from the Earth's crust are then put through a variety of processes designed to enhance their resistance to heat. Giant crushers begin the manufacturing process to transform the materials to ingredients necessary to produce refractories. The raw feed is screened and sized to ensure uniformity. Tons of materials move through sophisticated physical and chemical processing. The raw materials may be heated in giant industrial furnaces to drive off unwanted constituents and begin the necessary chemical reactions. Materials are then combined in exact proportion to meet specified formulas based on the particular application and the characteristics needed. Tons of material every day. Throughout the process, constant monitoring and testing ensure quality control. After mixing and blending to precise requirements, the subsequent manufacturing process can differ significantly. Refractory products are generally divided into two broad categories: preformed shapes and unformed compositions, generally called specialty or monolithic refractories. And then there are refractory ceramic fibers. Refractory ceramic fibers look similar to residential insulation, but insulate at much higher temperatures, up to 3,000 degrees. Bricks and shapes are the more traditional form of refractories, and historically have accounted for the majority of refractory production. Refractories come in all shapes and sizes. They can be pressed or molded for use in floors and walls, in interlocking shapes and wedges, or curved to fit the insides of boilers and ladles. Refractory bricks are usually manufactured using continuous assembly line operations, which ensure consistency and standardization of size and quality. Shapes can be manufactured in quantity or made one at a time for very specific applications. The variety of refractories reflects the wide range of the processes in which they are used. They can be very big or very small, depending on the application. Examples of such products are nozzles and lances for spraying and injecting materials in hot environments, runners, troughs, and gates for transporting and controlling the flow of molten materials. After they are pressed and formed, most bricks and shapes are then subjected to high temperatures over hours or even days to heat treat the materials and complete the necessary physical and chemical reactions needed in a finished refractory product. Heat treatment is done in large industrial furnaces and ovens, usually called kilns, which may be designed to operate continuously or intermittently. Tunnel kilns can be hundreds of feet long and hold dozens of cars. This ensures a continuous process and the efficient use of energy. Bricks and shapes are loaded on cars similar to small railroad cars, and then the cars are pushed into the front end of the kiln. As one car enters the kiln, one car exits the kiln at the back end. Periodic kilns are typically used to process small quantities of materials or large odd-shaped products. They are loaded when cool and then heated to a specified temperature for the time required. Material is removed after the kiln is cooled and the cycle is then repeated. Some refractory applications simply require low-temperature treatment to set a chemical bond prior to installation and use. Throughout the manufacturing process, constant monitoring is required. Temperature, chemistry, and engineering are all essential to guarantee performance. Testing and more testing, repeated again and again, to ensure the quality and integrity of the final product. Because of the ease of application for new installations and repair work, monolithic refractories now account for about half of refractory use. Monolithic refractories are generally sold as dry mixes. Various raw materials are sized and blended in large mixers to a specified formula and consistency. The material is then bagged and shipped for use. Some are packaged very much like concrete mix you might find in a hardware store. Monolithic refractories may be poured or pumped into place, sprayed onto surfaces, rammed, or applied with trowels or other tools. They can be precast into predetermined shapes, providing additional flexibility in application and use. Refractories. From the dawn of time to mankind's reach for the stars and beyond, we have relied on refractories to tame the flame. From the first tools to marvels not yet imagined, refractories make it possible.